The M1 Abrams is the U.S. main battle tank. It is in service with the U.S. Army and Marine Corps, as well as the armed forces of Egypt, Australia, Poland, Morocco, and a number of Middle Eastern states. Named after General Creighton Abrams. The crew consists of a commander, gunner, loader, and driver. The hull and turret of the tank are welded. Armored steel. In the front parts of the hull and turret, as well as in the sides of the turret, multi-layer passive armor was used in the form of combined armor modules, created on the basis of the English Cobham armor, Great Britain. Frontal armor is a multi-layer array up to 860 mm thick, consisting of 2 sheets of armor steel and a composite filler enclosed between them. The filler uses 5 types of ceramics, as well as Kevlar, titanium, textilite, polyurethane. The side armor of the tower is a layer of aluminum armor plates, a layer of air and 3 19 mm uranium ceramic plates, equivalent to about 500 to 600 mm of protection against cumulative ammunition. The Abrams also has knockout panels and walls that, in the event of an ammunition fire, remove combustion products from the tank to the outside, preventing an explosion, which increases the survival of the crew in battle. In addition to armor, some Abrams modifications are equipped with the Soft Kill Active Protection System, and/VLQ-6 Missile Countermeasures Device, MCD, which interferes with the tracking systems of semi-automatic anti-tank missile systems, for example, the Russian 9K-114 Sturm. Modifications M1 and M1IP are armed with a 105 mm M68A1 rifled gun, an upgraded version of the British L7, stabilized in 2 planes. The ammunition load includes 55 unitary shells with a metal sleeve of 5 types, armor-piercing feathered subcaliber shells with a detachable pallet M735, M774, M833, M900, cumulative shells M456A1 and M456A2, armor-piercing high-explosive M393A2, with ready-made arrow-shaped striking elements M494 and smoke M416, based on white phosphorus. Since 1985, the Abrams tanks have been equipped with a 120 mm M256 smoothbore gun, also stabilized in 2 planes. The ammunition load includes unitary shells with a partially combustible cartridge case. Auxiliary armament is represented by a 7.62 mm M240 machine gun coaxial with a cannon, a second machine gun of the same type mounted in front of the loader's hatch, and a 12.7 mm M2 machine gun mounted on the commander's cupola. In the M1A2 version, a Protector RWS remote-controlled module with a 12.7 mm M2 machine gun was installed. Ammunition: 11,400 rounds of 7.62 mm and 1,000 rounds of 12.7 mm. 266 mm 6-barreled M250 grenade launchers, 4 4-barreled M257 grenade launchers on the M1A1 and M1A1NS tanks of the Marine Corps, are installed on the sides of the tower to set up a smoke screen. The Abrams is equipped with one of the most modern Hughes aircraft fire control systems. A laser rangefinder and a thermal imaging camera are built into the gunner's main sight. The field of view of the sight has independent stabilization in the vertical plane. The day channel has 2 magnifications, 3 and 10, thermal imaging, 3, 6, 13, 25, and 50. The limits of measuring range with a laser rangefinder, from 200 to 7,990 meters. In case of failure of the main sight, a backup Kollmorgen Model 939 telescopic articulated sight with 8x magnification and an 8 degrees field of view is provided. The preparation time for the first shot when firing on the move is, by the gunner, 15 seconds, and by the commander, 17 seconds. When firing from a place, the time is reduced to 3 to 4 and 5 to 5.5 seconds, respectively. An electronic ballistic computer, made on solid-state elements, calculates with high accuracy the angular corrections for firing from a cannon and a machine gun coaxial with it. It automatically enters the range to the target, from the laser rangefinder, crosswind speed, angular velocity of the target and the angle of inclination of the axis of the trunnions of the gun. In addition, data on the type of projectile, barometric pressure, air temperature, charge temperature, bore wear, as well as corrections for mismatch between the direction of the axis of the bore and the line of sight are manually entered. On the M1A2, in front of the loader's hatch, a panoramic thermal imaging sight is installed, the CITV commander's observation device, which has independent stabilization in 2 planes. Instead of a rotating turret, a fixed one with 8 periscopes was installed, providing a much better all-round view. The M938 sight has been removed. The gunner's main sight has been significantly upgraded, it has received independent stabilization in 2 planes, the laser rangefinder has been replaced with a more advanced carbon dioxide-powered one. Also, a thermal night vision device is installed at the driver's side, instead of a night vision device with an image intensifier tube. The disadvantage of the M1A1 is the limited ability of the commander to independently search for a target, a small increase and the lack of stabilization of the field of view of the M919 sight do not allow confident detection and identification of targets when the tank is moving. This drawback was eliminated on the M1A2 modification. The M1A2 gunner's sight has been significantly upgraded, it has received independent stabilization in 2 planes. M1A2 SEP received 2nd-generation thermal imaging cameras for the gunner and commander. The onboard equipment has been improved. A tank information and control system, TIUS, IVAS, an inertial navigation system, and SINCARS radio stations have been introduced. The individual electronic systems are interconnected via a MIL STD1553D data bus. Since TIUS IVAS was outdated by the time it was put into service, it was replaced on the M1A2 SEP model with the FBCB2 Epler's Troop Control System. In addition, the M1A2 SEP received 2nd-generation thermal imaging cameras for the gunner and commander. The navigation system is supplemented by the Navstar receiver. ACCS terminals FBCB2 BFT, unified in software with FBCB2 Epler's, but using commercial satellite communications networks Inmarsat Swift 64 and BGAN for data transmission, are installed during the modernization of M1A1 under the AIM program. The Avco Lycoming AGT1500 gas turbine engine is made in a single unit with an X1100-3B automatic hydromechanical transmission. A block weighing 3,860 kilograms can be replaced in less than 1 hour. Since the mid-1990s, Abrams tanks have been massively equipped with auxiliary power units, APUs, which provide power to the onboard systems of the tank without turning on the main power plant or running out of battery power for 7.5 to 8 hours. The undercarriage of the tank includes 7 road wheels with external shock absorption and 2 supporting rollers on each side, a torsion bar suspension and tracks with a rubber metal hinge and rubber shoes. M1 Abrams is currently one of the heaviest tanks, its combat weight exceeded 62 tons.